I am looking at Anne's very nice video on the Secret Santa puzzle, and I haven't gotten to her conclusion yet. I got distracted and thought, what would this look like in R? So I've put together a little bit of code. Let me explain that. It's currently running a simulation of 10 million hat pulls. And it's doing that to try to estimate this the lazy but intense way. So let me show you what I've got. So I'm using the tidyverse because that just makes R easier. I've gotten used to that. Made a simple function here called pull names from hat, which takes an argument of n. So we've got 5 people. If we pull 5 names from a hat, sometimes we get false and sometimes we get who should get matched up with who. So the first person buys for person 5, second for number 1, third for 4, fourth for 2, and fifth for 3. So this is just me, and I literally wrote this from top to bottom and barely made any edits. So I just said, let's make up our group, people from 1 to n. We don't need to name them. We just need to say there's someone is maybe the first in the alphabet, and then the nth, right, or the fifth. And then I just say gifts sample group, and what that does is it just shuffles these numbers from 1 to 5. And then I ask, is that equal, double equal for comparison, to 1 to 5? And what we see in this case, whatever sample it was behind the scenes here, I had 2, 3, and 4 in these places. So I guess this would have had to have been 5 and this would have had to have been 1. I'm going to do this again. It's going to again make some random set, but it's going to be asking, are they equal to 1 to 5? So in this case, 3 was in here. The other 4 were properly shuffled. So this function, this does exactly what they want. It says, all right, there are how many of us? Let's give each of us a number. Let's shuffle those numbers, and then we'll just dole them out in order, right? So that everyone gets 1. And then it's asking like this, does anyone have this? And this any function will compress this into a single number. Oops, I have to put this in parentheses. Right, so this is saying out of the sample from 1 to 5, the shuffling, are any of them in the order 1 to 5? Are any of them in that order? In this random sample, it was true. In these samples, it was false. So if my question is, what's the probability that we get a false or that we get a true, I don't really want these actual names. I just want, did we match them? Did we get a good match, or did we get a match where we have to put everyone's name back in the hat and redo it? So all of this logic we can compress into a simpler thing. So here we're saying not any. So let's walk through this. We'll peel away the layers here. Any 1 to n equals sample 1 to n. And this is like what we were doing. So I'm going to swap out 5 for n. So again, we're asking, give this vector from 1 to 5, compare that with a sample of 1 to 5, so shuffle that same vector, and then ask for that comparison element-wise, is it true for any of them? And then this negates that. So we go 1 to 5. We go sample 1 to 5. We ask for some sample, is it equal to 1 to 5? Right? In this case, we got a good shuffle, but if we do that again, sometimes we get 3, 4, 5 in both sides. Now in this case, I've got the order in the other direction, but it doesn't really matter. And then I can ask the sample 1 to 5, is it equal to sample of 1 to 5? And then I negate that. And now this is telling me the opposite of what I get here. So here I'm asking, did we make any mistakes? And we get success if we did not make any mistakes. So this gives us the basic logic, and it's going to return true or false. And then to simulate this, I've made a really simple little wrapper for this bit of logic, which is I want to map over n, right? I want to plug a bunch of n values into the simulate success function. So what I'm going to do is I'm going to repeat n a bunch of times. If I wanted to do, say, 5 people 10 times, rep 510 gives me a bunch of that. And then I'm repeating for each element in this vector, I'm plugging that into simulate success. Right? So if I go map rep 510 onto simulate success, I'm going to get 10 results. And by doing map underscore logical, I get that back as a Boolean vector. So this is the simulation. And here I did it as simulate many hats, where we're taking in how many people, how many repetitions, and then that will basically plug those numbers into here and return some result. Now I ran that just as we started recording, and then we lost it. Where did it go? Simulate success, simulate many hats. There was 100. Oh, here we go. And then I was plugging it into mean. So out of those 1 million that I ran, 10 million, sorry, out of 10 million hats that we pulled, we got 3.666585 million successes. So more than a third, less than 40%. Now, is this the actual analytical solution? I don't know. I'm looking forward to seeing how close Ann gets to this. That'll tell me how good my simulation was. But this is it in R. Let me just give you that once over once again. We figure out the basic logic. We strip it down to the bare essential. And then we repeat it 10 million times, or some large number of times. When I did this 10,000 times, I got 0.3601. I did that a few times, or I did that twice. So I got 2 different numbers, but both 3.6 something. 3.5 something before, 3.8 when I only did it 100 times, and then whatever the result is here where I did it 100 times. But let's say my best estimate so far was 3.666. Cool. I'm going to share this and then I'm going to finish watching Ann's version.